السلام عليكم ورحمة الله وبركاته، طلبة وطالبات الصف الثالث الثانوي علم الرياضة. ريفيجن جديدة من الداينامكس ريفيجنز. A body of mass 4 gram moves where its position vector is determined from the relation R equal, then the momentum vector after 2 seconds equals. We must find S. Displacement S equal R minus R node equals ال R اللي هي ال given vector 3t plus 4 in the I direction plus 8t minus t square in the J direction minus the same direction R where t 0 يبقى 0 plus 4 in the direction I plus 0 minus 0 in the direction J. So L4 will be cancelled with 4 in the direction I. S equals 3t in the direction I plus 8t minus t square in the direction J. We must find V, the velocity, equal ds by dt equals 3 in the direction I plus 8 minus 2t in the direction J. At t equal to S equals V equals 3i plus 2 times 2 4 8 minus 4 4j since in H momentum vector equals m multiplied by v, m is 4 multiplied by 3i plus 4j. So the answer is number A, 4 multiplied by 3i plus 4j. Number 2. A ball of mass 800 grams fell down from a height 2.5 meter on the surface of a viscous liquid and penetrates it with uniform velocity of magnitude 2 meters per second. Then the magnitude of the impulse of liquid on the ball in Newton per second. Dot unit. We have the ball and this height 2.5. عايزين نجيب impulse of liquid on the ball. We must find the velocity before entering the liquid. Here we use v square equal v node square plus 2gs. V square equal v node 0 because it is fell down, 2 times g 9.8 times s 2.5. the result will be 49. Take the square root, v1 7 meter per second, the velocity before entering the liquid directly. Inside the liquid, V2 is uniform velocity equal to centimeter per second. So I equal impulse equal a change in momentum m v1 minus v2. M 800 gram بالكيلوغرام 0.8 multiplied by 7 v1 minus v2 2. 7 minus 2 5 times 0.8. the result will be 4. The magnitude of work needed to done to raise 5 meter cube of water up for 10 meters equals. We know that the volume from here is meter cube, 5 meter cube. الماث equal the mass equal the velocity times the density. The mass equals the volume times the density. The volume 5 meter cube. The density of water is 1. So الماس equal 5 times 1000 equal 5000 kilogram. الورك اف دوت اس، الاف ام جي اس، ام جي الفورس هنا الويت ام جي 5000 times 9.8 times 10. Therefore the result will be 490,000 joule. The answer is C. An inclined plane of length 4.5 meter and its height 2.7 meter. A particle is placed, so mg sin theta, component of it on the line of the greatest slope, mg cosine theta, that's n, and mu n. n equal mg cosine theta. Equation of motion mg sin theta minus mu n equal ma. mg sin theta minus الميو اللي هي الميو 0.5 الN mg cosine theta equals ma divided by m. G 9.8 sin theta 2.7 over 4.5 minus 0.5 times G 9.8 cosine theta 3.6 over 4.5 equals A. Therefore A equals 1.96 meter per second square. So it is equal 196 centimeter per second square. The answer is B. A bullet is fired horizontally towards a piece of wood with velocity 216 km per hour to be at rest inside it at depth 20 cm. If the same bullet is fired with the same velocity towards the fixed target made of the same wood of thickness 15 cm, what is the velocity at which the bullet will get out the target, assuming that the resistance is constant? So we have a target, the bullet fired on it and become at rest after 20 cm inside it. So V1 equal 216 times 5 over 18, it will be 60 km per hour. Since V square equal V node square plus 2AS, V equal 0 because become at rest. V node 60 square plus 2 times the acceleration S 20 centimeter, it means 0.2 meter. Therefore A equal negative 9,000 meter per second square. We have another target of the same thickness and the same resistance. The bullet fired on it by the same velocity 60 km per hour and get out it after 15 centimeter. It got out. So we want to find this velocity V2. Since in V square equal V node square plus 2AS, since the second target from the same matter and the same thickness and the same resistance, so the acceleration doesn't change. A is negative 9,000 equals V node square 60 square plus 2 times A negative 9,000 times S 15, it means 0.15 meter. It will be 900. So V2 equals root 900 equals 30 meter per second. This is the velocity by which the bullet will get out from the second target. Also find the magnitude of the resistance if the mass of the bullet 0.98. In the first target, the equation of motion, any moving body, we can apply this equation on it. F minus R equal ma. There is no motor for the bullet. F equal 0 minus R equal m 0.98 times the acceleration negative 9,000. So R equal 8,820 Newton. Two smooth balls of mass 20 gram and 50 gram. Move on a smooth horizontal land in one straight line. The velocity of the first ball is 30 cm per second. The velocity of the second ball 20 cm per second in the opposite direction. The first ball rebounded after collision with velocity 10 cm per second. Determine the magnitude and the direction of the velocity of the second ball after collision directly. We have two small balls move in a smooth horizontal plane. This is the first ball, this is the second ball in opposite direction. We shall make the direction of the first ball is the positive direction. This is in the positive direction. So we have V1 equals 30N. V2 moves in the second direction, so it will be negative 20N. The first ball rebounded after the collision with velocity V-1 in the opposite direction, negative 10N. In the collision, M1 V1 plus M2 V2 equals M1 V-1 plus M2 V-2. Therefore, M1 20 gram times V1 30N plus M2 50 gram multiplied by V2 negative 20N. M1 V-1 M1 20 multiplied by negative 10N plus M2 50 multiplied by V2 dash unknown. Therefore 20 times 30 600 minus 1000 N will be negative 400 N equals 20 times 10 negative 210 negative 200 N plus 50 N 50 V dash 2. Therefore V-2 equals Negative 400 plus 200, negative 200 n divided by 50. It will be negative 4n. So V2 equal 4 as a magnitude, centimeter per second. The sign is negative, so it is in the same direction. The second ball moves in the same direction because it moves in the opposite direction of positive direction. So in the same direction. A particle moves under the action of two forces F1 and F2. F1 and F2 are measured in Newton. Then the magnitude of extra force in Newton, which if it acts on the body, it will make it move with the uniform velocity. So the extra force equals the resultant of the two forces but in the other direction. R equals F1 plus F2 as vectors. Negative 4i plus 1i, negative 3i, 5j plus negative 1, positive 4j. This is the extra force equal the resultant of the two forces. So norm F equal norm R equals the square root 3 square plus 4 square equal 5 Newton. The answer is C. The magnitude in Newton of the force which acts on a body of mass 5 kg to move it with acceleration F equal ma. الماس 5 الاكسلريشن 2 كيلوغرام with meter 10 كيلوغرام دوت meter per second square. So the answer is 10. A person of mass 73.5 kilograms inside a lift. Answer the following. Determine the reaction of the lift in kilogram if the lift moved with uniform acceleration vertically upwards. Number A. In case of motion vertically upwards, R equal M multiplied by G plus A. From the equation of motion. R equal mg plus A. Therefore, M is 73.5 kilogram. J 9.8. 140 centimeter per second means 1.4 meter equals 823.2 Newton divided by 9.8 equals 84 kilogram weight. B. Determine the reaction of lift in kilogram if the lift moves the uniform acceleration 140 vertically downwards. In the case of vertically downwards, R equal M multiplied by G minus A. 73.5 multiplied by 9.8 minus 1.4. it will be 617.4 Newton divided by 9.8. It will be 63 kilogram weight. A particle started its motion in the straight line from the origin point with initial velocity v0 3 meter per second. If the acceleration of motion after t second is given by 6t minus 4, find the displacement after 2 seconds from the starting motion. V equal integration a dt equals integration 6t minus 4 dt equals 6t square divided to 3t square minus 4 integration 4 according to t equal 4t plus constant c. If the acceleration motion from the origin point with initial velocity 3, v equals 3 when t equals 0, v equals 3 when t equals 0 because in the beginning of motion plus c, therefore c equals 3, therefore v equal 3t square minus 4t plus 3. Find the displacement after 2 seconds from the starting motion. S equal integration v dt equals integration 3t power 2 minus 4t plus 3 dt. S equals 3t power 3 divided 3 will be t power 3 minus 4t square divided to 2 square plus 3t plus a new constant c1. In the beginning of motion s is 0 when t is 0, therefore c1 equals 0, therefore s equals t power 3 minus 2t power 2 plus 3t, t equal 2, therefore s equal, find the displacement after 2 seconds. 2 power 3 8, 2 times 2 power 2 8 plus 3 times 2 6, so the answer will be 6 meter. Number 11. A body moves in a straight line with velocity v equals 6 minus 2t. If the body started its motion when it was at distance 3 centimeter of the region on the straight line at the instant of beginning of motion, then the total distance in centimeter in the time interval from 1 to 5. The velocity is a function from the first degree, so we can represent it by a straight line. This is t. When t equals 0, the velocity equals 6. So the first point on the straight line. When t equals 0, v equals 6. When v equals 0, t equals 3. When v equals 0, 2t equals 6, t equals 3. So this is another point. When t equal, this is 3, this is 1. When t equal 5, 2 times 5, 10, 6 minus 10, negative 4. This is negative 4. So we can graph the straight line. We want to find the displacement in the interval from 1 to 5. S equal integration v dt. From 1 to 5, integration velocity equal area under the curve. So from 1 to 3 there is an area here. From 3 to 5 there is another area. The sum of the total area of the two triangles is equal to the displacement from 1 to 5 equal area from 1 to 3 plus area from 3 to 5, because the integration of any curve equal area under this curve. When t equal 1, therefore v equal 6 minus 2 times 1 equal 4. So this vertical is 4. Vertical distance is 4. This vertical is 4 in the negative direction, negative 4. This means as a length 4 and 3 from 5 2 units. S equal area 1 plus area 2 equal half base from 1 to 3 2 units, from 1 to 3 2 units, times the height is 4 plus half times base here is 2 units times its height is 4. So 4 plus 4 equals 8. So the answer is 8. The total displacement from 1 to 5 is 8 units. Number 12, at a moment the momentum of a body 112 kilogram dot meter per second. Its kinetic energy 80 kilogram weight dot meter. We have H equal mv equal 112. Have mv square kinetic energy, have mv square equal 80 kilogram weight. It will be 80 times 9.8. Dividing, therefore H or mv dividing half mv square equal 112 divided by 80 times 9.8. Therefore cancel m with m, will be 2 over v equals 1 over 7. Therefore v equal 14 in 1. This is equation number 1. m times 7 equal 112. m times 14 equal 112. m equal 112 divided 14 equal 8. Number 13, the power of a machine in horse equals 6t minus 1 over 20t square, where t is the time in second, where t belongs to the closed interval from 0 to 120. Then the maximum power. Look carefully to this function. It is a function from the second degree, so it is up and down because the coefficient of t square is negative. If we graph it, we will get function like this. So the maximum value at the vertex, the maximum value to that function at the curve of the curve at the vertex. We can find the vertex, as we know, as we studied before. The x coordinate of the vertex equal negative b over 2a. Negative b, it means negative 6 over 2 times a, negative 1 over 20. Use the calculator, it will be 60. So f of 60 equals 6 times 60 minus 1 over 20 times 60 square. f of 60 اللي عندها الماكسيمم فاليو equal 180 horse. A smooth pulley is fixed vertically. A light string passes over the pulley. At one of its ends, a body of mass 60 gram is suspended, and the other end, two masses of magnitude 4 to 50 gram are suspended. If the system started the motion from the rest, find the acceleration of the motion. So we have a smooth pulley, and the string carries two particle 40 and 50. So mg is 90g. In the other side, this is 60, therefore mg here is 60g. The tension are equal in the two branches of the string because the pulley is smooth. The system will move downwards in this direction because the mass here is greater than 60. The first equation, mg 90g minus t equals ma 90a. This is number one. Therefore, the second part, t minus 60g equals 60a. Tension minus mg equal ma. This is number two. By adding negative t plus t0, 90g minus 60, 30g equals 90 plus 60, 150a. Therefore, a equals 30g, 30 times 9.8 divided 150. It will be 1.96 centimeter per second square. This is the acceleration of motion. If the body whose mass 50 gram is released after 2 seconds from the starting motion, يبقى احنا لازم نجيب الفيلوسيتي بتاع السيستم قبل ما نشيل ال 50 دي. بعد 2 seconds يعني هنجيب الفيلوسيتي بتاع السيستم قبل ما نرفع ال 50 دي مباشرة. V equal V node or U plus AT. V equal V node 0. الأكسلريشن 1.96 times 2 will be 3.92 centimeter per second. The equation of motion 40g minus t1, the tension will change, equal ma 40a. This a will be a dash. There is a new acceleration after releasing the mass 50. This is number 3. And T1 minus 60g equals 60a dash. Number 4. By adding T1 cancel negative T1, 4 to negative 60, negative 20j equals 40 plus 60, 100a dash. This is the new acceleration after releasing the mass 50. Therefore, a dash equal negative 20 times g 9.8 over 100 equals negative negative 1.96 centimeter per second square. We want to prove that the system will be at rest after 2 seconds from the releasing the 50 gram. So we have V equal V node plus AT. The system will be rest يبقى V equal 0. V node النود هنا اللي هي الفيلوسيتي اللي احنا جبناها في نهاية المرحلة الأولانية اللي هي 3.9 before releasing 50 directly, 3.92 plus the acceleration negative 1.96 96 times the time t. Therefore, t equals 3.92 divided by 1.96 equals 2 seconds. So the system will be at rest after 2 seconds from the releasing the 50 gram. A body moves in a straight line with uniform acceleration A equal negative 3 centimeter per second square and initial velocity v naught 5 or u. If the mass of the body 18 kilogram, find the magnitude of the change in the momentum in the interval from 1 to 2. V equals integration A dt. Since H equal mv, therefore H equals integration because the m is constant A dt from 1 to 2. H equals the change in momentum equals integration negative 3 dt from 1 to 2 equal negative 3t. We have m negative 3t from 1 to 2. M equals 18 kilogram. Integration negative 3t from 1 to 2. We have did the integration equals 18 multiplied by negative 3 times 2 minus negative 3 times 1 equals negative 6 minus 3 equal negative 54 kilogram dot meter per second. So therefore it will change as a magnitude, it will change in H equals 54 kilogram dot meter per second. Sixteen. If the system moved from the rest, then the magnitude of the pressure. The pressure on the poli is the resultant of the two forces T. This angle theta, this 90, this angle 90 minus theta. So tension, pressure equal square root F1 square plus F2 square, T square plus T square plus 2 times F1T times F2T cosine 90 minus theta. P equals square root T square plus T square 2T square plus 2 times T times T 2T square. Cosine 90 minus theta will be sine theta. Sine theta equals square root, take 2T square common factor, therefore the remainder is 1 plus sine theta equals T root T square is T square root 2 multiplied by 1 plus sine theta. The answer is C. A motor bicycle of power 4 horse moves on horizontal road and its maximum velocity 36 km per hour. Find the resistance of motion bicycle. Since the particle moves with maximum velocity, therefore F equal R. In case of maximum velocity, there is no acceleration, F equal R. Since power equal F times V, الباور 4 horse times 75 عشان تبقى بالكيلوجرام ويت. الفورس unknown. total velocity الvelocity 36 times 5 over 18, so it will be 10F. Therefore F equals 4 times 75 divided by 10, it will be 30 kilogram weight. Therefore R equals 30 kilogram weight. If the bike ascends an inclined plane to the horizontal with angle theta and the sin theta is 1 over 24 plus resistance R, the resistance of the road didn't change, so R here is 30, and you have F. So therefore the equation of motion F equals R plus mg sin theta. Therefore F equals R30 plus mg 240 kilogram times g 9.8 times theta 1 over 24 equals 128 kilogram weight. The inclined plane with angle theta or sin theta 1 over 24, we have mg sin theta plus R resistance because the particle moves up. Therefore F equals, or you can call it F dash. F dash will change. F on the horizontal plane not equal F on the inclined plane. F equal mg sin theta plus R. R ب 30 plus mg m 240 times sin theta 1 over 24 will be 40 كيلوغرام وي. هنلاحظ هنا انا ما حطيتش الجي، ما حطيتش هنا 240 جي، ما حطيناش الجي ب 9.8 عشان تبقى تفضل بالكيلوغرام ويت زي دي بالكيلوغرام ويت. لو كنا حطينا الجي ب 9.8 كنا لازم نعمل دي تايمز 9.8. therefore F dash equal الباور divided V dash. therefore F dash 40. The force is 4 times 75 300 divided 40 10 over 5 equals 27 kilometer per hour. A body moves in a straight line under the action of a variant force F equal 1 over 5x Newton, where x in meter. It represents the distance between the body and the origin point. Calculate the work needed by this force when the body moves from x to 0 to x to 10. A. Since in the work equal integration f dx, because f is a function of x from 0 to 10, so it will be equal integration 1 over 5x dx from 0 to 10 equals 1 over 10 x square from 0 to 10 equal 100 over 10 minus 0 equal 10 joule. B. The work done by the force integration from 1 to 5 1 over 5 x dx equals 1 over 10 x square from 1 to 5 equals 5 square 25 over 10 minus 1 square 1 over 10. It will be 24 over 10. It means 2.4 joule. بشكركم لحسن المتابعة، وإن شاء الله يكون في استفادة، ونرجو متابعة الجديد.